Let's start with number 10. Oh, look, there's drawing on this one. Okay, so degree 4 positive a value. Degree 4 positive a means that you're going to have both arrows up. Okay, so I need it to have 4 directions. So 1, 2, 3, 4. Again, yours does not have to look like mine. It just needs to have 4 directions. You can make your bump as high or as low as you want. 1, 2, 3, 4 directions. Both arrows going up. If x is going to negative infinity, y is going. If x is going to infinity, y is going. Top line is the left arrow, bottom line is the right arrow. Left arrow up, right arrow up. Okay, now move down to number 14. This one needs a box. It's squared, so that means that I'm going to have the same thing on the top and the side. I want to make sure that you guys see that this is not a conjugate. The conjugate would be plus and minus. This one, they're both minus. So it's not a conjugate, which is unfortunate because that means I need to do all the boxes. Anyway, 6 times 6, 36, 24i, 24i. Okay, let's go slow here. Negative times a negative is a positive. 4 times 4 is 16. I times I is I squared. What does 16i squared simplify to? Okay, so the I squared part of it is -1. So this is 16 times -1, which is negative 16. Okay, so you have 36 plus, and then I combine these guys, 48i minus 16. And then 36 minus 16 is 20, so 20 plus 48i. Okay. Are you guys ready to draw? It's going to be great. You're going to love it. Surprise avalanche. In the classwork today, I'm going to use blue pen and red pen. So if you're the type of person who likes to color things, get out some other color to use also. Oh, Sophia, I like your cup. Did you see? Miss Rice got me this for my birthday. No, for Christmas this year. Woo. Okay, on these first two problems, there's drawing on both of them. Um, our goal is to identify the degree, which is kind of a little bit of a lie. It's technically the minimum degree because remember, like a bounce could still be like, but whatever. In this class, we're just gonna say the degree and then describe the roots completely. So in the first two problems, put my phone up. Oh my gosh. Okay, in the first two problems, our goal is to determine the degree and to describe the roots. Okay, now do you guys remember what I said about the fundamental theorem of algebra? It's got the word fundamental in it. That must mean it's importante. The number of roots matches the degree. The number of roots matches the degree. If you can remember that, then you are set for this lesson, these first two problems. Okay, starting with A. What is the degree? 2. Okay, does anyone need to ask me why the degree is 2? You do need to ask me why the degree is 2? Well, no, it's because it has 2 directions. So down, up is 2 things. So it's degree 2. Okay, now I'm going to take my red pen and I'm going to find the x-intercepts, which I also call roots, which I also call zeros. But those are my x-intercepts. By the way, I noticed on the NWA, some of the questions asked about the zeros, and I was like, we just did that. Even though I'm not supposed to look at the NWA, I sort of cheated, looked at it. That's cool. I don't yet, but I have it printed right here. Okay, anyway, these are 2 single real roots. Okay, so that is stating the degree and fully describing the root. The degree 2, because it's 2 directions, 2 single real roots. Let's talk about why they're single. There's no bounce or inflection point, correct? Okay, and real because they actually cross the x-axis. Okay, are you with me? Are you with me? Okay, all right, so B, what is the degree? Degree 3. 1, 2, 3. Okay. I find 3 crosses of the x-axis, 3 single real roots. I like to call it complex, even though it's might not be complex. Well, they're definitely all complex. Just so you know, I'm simplifying the degree and I'm simplifying the description here for this class. If this was calculus, I would say something different. Okay, anyway, C, what is the degree? 2, degree 2, wonderful. Oh, let me hunt for those x-intercepts. Oh no, I don't see any. Okay, but Mrs. Talbot told me that the fundamental theorem of algebra says that there has to be 2 roots. What kind are they if I can't see them? Yeah. Right, okay. Now they're imaginary, but we don't say that. We're going to say 2 single complex roots. And the reason we're going to say complex is because they might be like 3 plus 4i, where there's a real component and an imaginary component. But I sort of wanted to say, I wanted to steer you toward the word imaginary. We're going to use complex in this case. Okay, so the goal here is, okay, I find out how many real ones there are, and then everything else will be complex. And all complexes are single for us because they're plus and minus. Okay, so now what we've learned, D, what is the degree? Yep, degree 3, beautiful. 1, 2, 3, gorgeous. Okay, now this one has one cross of the x-axis. So I know there's one single real root. But fundamental theorem of algebra says that there has to be 3 total. So the other 2 are complex. Okay, now I want to really quick before we move on from this. I'm good. Okay. Any of you guys watch Sports Center, football? There's this guy that like he does the fastest 2 minutes in television. 16 minutes. Okay, he makes this sound when he's describing what happens in football games, and he goes over the highlights basically, and he makes this funny sound every time that he does this bit. And it's okay, and so it's like a juke in football where they like go like this, right? So they're like going to the side. You guys know what I'm talking about? Okay, and the guy on Sports Center, he plays all these little videos, and then like the football player, shifts over and he goes, woo, and it's like over and over again. Okay, anyway, I'm saying this for a reason, I promise you. The complex roots do a little woo. Okay, so I'm saying that because I want to bury that in your head. On the second quiz, I'm going to ask you to graph something that has one real root or 2 real roots or a double root or something. And I'm going to say I also want 2 complex roots. And what I'm expecting you to do is draw whatever I ask for the x-axis, and then for the complex, I'm going to ask you to go, I'm going to ask you to come toward the x-axis and be like, nope, I'm not going to cross it. I'm going to go the other way. And that's where your complex comes from. It comes from this little, like, I call it the fake out. So it's like, okay, it's going to come towards, like, you cross and move up. And that's where your complex ones come from. So that's how you play those. You guys are like, what is that guy's name? Chris Burley. Yeah, that was gonna bug me. Fastest 2 minutes in television? Yeah, you guys should Google it, and then you'll know I'm not. I mean, I'm not crazy for that. I might be crazy, but that's not the reason. Just anyway. You should look it up. It's funny. If you like football at all, it's good. It used to be way more popular than it is now, but It's most kind of out. What? 156 most. It means like I get along with almost everybody. There's just like, you know, a few people out there that just they can't handle my perkiness. I'm perky. You know, I'm upbeat, positive. Some people can't handle that. Also, there are some people that bully me because I'm nice. Yeah. I'm not gonna tell you.
My mom thinking of job applications, I walked into her work and then some advice to get information back home.
You're so cute. I don't have the social. Anyway, okay. If you have finished drawing these four, you are done drawing. Woo! Aren't you excited? Okay. Our goal for these four is exactly the same as our goal for the previous one, except for that I told you that the degree is 3, so we don't have to state that every time. Okay, I also really wanted to state that for this one. These are all different x cubed options. These are not the only x cubed options, but these are some x cubed options. So I just want to make sure that we fully describe. So 1, 2, 3. How many should there be? 3, because the cubed. So this is 3 single real roots. You guys okay? Okay. Now, this one. This one is 1 single real root and 1 double real root. It's double because it hits the x-axis and bounces. So 1 single real root, 1 double real root. Now contrast that with this one. This one actually touched. This one does not. That's why I put them next to each other. So this one is 1 single real root, and then it never crosses again. It does my little whoop. 2 single complex roots. Make sure you see the difference between this and this. Okay, last one. What is this called? What is it? Triple. 1 triple real root. What is the vocab word for this right here? Inflection point. Okay. We're halfway there, halfway home, people. Okay, are you guys getting what I'm trying to say here? So the total has to be 3. This gave you 3 right away. This is 1, and then 2, 3. This is 1. So the other 2 have to be complex. Yes, honey. Well, they're all degree 3. So I was too lazy to write it. So up here, I said y equals x cubed parent graph, which means that they are all degree 3. I just sort of covered the whole problem with that little statement right there because I was too lazy to say degree 3, degree 3, degree 3, degree 3. Okay.
Don't put it on the bottom and get marked off point.
It depends on the directions. So if the directions say state the degree, you should probably state the degree.
Down.
Okay, so for 74, we're starting with a cubic, that's a degree 3. And you guys do not know how to factor it out yet. Guess what I'm teaching you on Tuesday, Wednesday of next week? How to factor a cubic. Okay, but today I gave it to you. So this is the last time. 3D factor of a cubic for you. By the way, it's not hard at all. Don't worry. It's not a hard thing to learn. It's I actually really like it. Anyway, so this is the factored form of this. Now technically, I'm going to take a Post-it. Don't write this. I should check to see if this is factorable. I'm going to tell you that it's not because the top would be 1x squared and the bottom would be negative x. Does that diamond work? No. So this is how you know that this factored form is done. So we're going to go, okay, this is our factored form. This is as factored as we can possibly get it because the diamond doesn't work. Okay, I am going to find the roots. Can you guys tell that this one's going to be nice and these two are probably not going to be nice because it wasn't factorable? What do you predict they're going to be? Yeah, okay, I see. You see where this is going. Okay, so first thing I'm going to do is say, okay, I'm finding roots, so I have to set it equal to 0. And for this piece, I can just go x equals 2. Since this is an exponent of 1, there's not a squared or anything on there. I know that's one single real root, and that description is done. So the goal on these two problems is exactly the same goal as the ones we did from the graph. It's just we're figuring it out algebraically. Okay, so now this, what do we do to solve a quadratic when it's not factorable? It's your favorite. What? When it's not box and diamondable. Quadratic formula. Oh, you love it. Okay. A equals 1, B equals -1, C equals 1. Do you guys all see where I got those from? 1, -1, 1. Okay, over here, you might, if you just, need it. If you don't need it, that's fine. But if you do need it, go ahead. Negative b is +1, plus or minus square root b squared minus 4ac all over 2a. Okay, x equals 1 plus or minus square root. Okay, so -1 times itself is +1. +1 minus 4 is -3. Okay, and then the -3 becomes I√3. Okay, what would my description for these be? Because there's i's in there. 2, single, double, triple. Do you know what they are? It's single. The reason it's single is because one of them's plus and one of them is minus, so they're not exactly the same thing. Complex, and the reason it's complex is because there's an I in the problem. Roots. That gives us our total of 3. right, we have one more. This one is already factored for you. This is factored form already. I'm just telling you this because this part is not factorable. So I say 0 equals x squared plus x minus 1. We're finding roots or zeros or x-intercepts. You always want to put y as 0. Okay, and then this piece, x, you just bring that off to the front and say x equals 0. If you guys remember, the plain x in the front is 0. And that's one single real root. This again is not factorable, so I'm going to go to quad formula. A equals 1, B equals 1, C equals -1. X equals negative B plus or minus square root B squared minus 4AC all over 2A. Okay, what's the value of this mental math wise? 5. This is 1, and then this becomes plus 4. So 1 plus 4 is 5 over 2. Okay, so I know I have a plus or minus, so that gives me 2 single. Question is, are these real or complex? This is the last bit of thinking you need to do. Are they real or complex? Real. And they're real because there's no I in there. They're just gross decimals, but they're real. Okay. Now, last thing, can you guys get out your quiz review and please take a look at it and see if there's anything you want to ask me? Yeah, yeah. Number 10? Okay. Now, I'm going to tell you, okay, there's a couple things I want to tell you about number 10. But, okay, so we have y equals a, and the 0 is a plain x. And then we have x minus 2, x minus 5, x plus 12. Okay. And then you plug this in. What did you get for A? I think that's 4. Okay. Before I go on, the quiz we have tomorrow, the directions say factored form. So you would leave it here. This particular problem in the quiz review says standard form because I want you to practice that. But that's not what I'm going to ask you tomorrow. So on your quiz tomorrow, you would leave that. That would be final answer and you're done. Okay. Okay. Now let's just talk about the standard form part. let me just finish it. Okay, so what I would do personally is I would just take these two guys here and I would make a 2 by 2. So that would give me y equals 4x, x minus 2, x squared plus 7x minus 60. Does that make sense so far? Okay, and then I would do a 2 by 3 box with those two. You see where this is going? So like, and then I would distribute the 4x to all of them, and then you get the final answer.
Okay.
But again, I'm not going to ask you for that tomorrow. This is just practicing for future. I don't know. Does anybody know what 74 times 4 is? It's 3. 296. Okay. Also, is that the correct answer? Did anyone check the answer key? It is, okay. I feel like these problems aren't hard, but I feel like they're susceptible to little tiny errors in them with like negatives and positives and like, 4 times 5 is 15, or, just some little thing. Like they're not hard, they're just tedious. Anything else from the quiz review you guys want to talk about? Connor, I'll let you have this paper in a second.
Right.
You guys good otherwise? Okay, so you have 15 minutes if you want to ask me questions individually at any point. There's only 3 questions for homework, which is great. I do have a joke for you. It's not in this. I don't know what the heck I'm selecting here. Okay, really special right now. I'm just completely unable to find my, oh, okay, here we go. 72 to 75 real and complex roots. We did that. Yep. Homework is 77, 78, 79, and this says, why are you turning in a blank sheet of paper? And the guy says, because all my answers are imaginary numbers. That's a good one for today.